All right, so we left off after, 14. Oh, we did 14. Cool. All right, so 16 is solving the equation on the interval from 0 less than or equal to x less than or equal to 2 pi. And so the problem is 5 plus 2 sine x minus 7 equals 0. So 5 minus 7 is negative 2, so I'm just going to add that over here. So 2 is equal to 2 sine x. And divide by 2. Sine of x is equal to 1. So where is sine of x equal to 1? In radians, I should say.
Pi over 2?
Yep, pi over 2. And I said in radians because that's what the interval is given to us. If the interval was given to you in degrees, we'd give degrees. So pi over 2. And this one, because it is a specific interval, the only place that it occurs is at pi over 2. So we just do a specific solution.
I'm looking at tangent. I'm like, without a tangent, how did he get that?
I forgot about it.
I did too.
I thought like the rhyme of like what?
I know. I saw you peek up. You like.
You're like, huh?
Yeah, for real.
And we can check the specific ones, or well, technically we should check the specific ones by plugging it back in. So 5 plus 2 sine of pi over 2 minus 7. So sine of pi over 2 we just said is 1. So 5 plus 2 minus 7. So 0 equals 0. So that's good.
Wait, why did we take out the sign? Pi over 2?
It would just became 1.
Oh, okay.
But we just have to check the specific ones to make sure that they actually work, because sometimes you might get 2 answers, but when you go to plug it back in, it might not actually like make the statement true. So.
Oh, so whatever, like, if we put like in like sign, like for this one, where we put sign pi over 2, it just becomes whatever the like sign equals, the sign of x equals.
Basically, yeah. But like some of them that have like the 2 answers, or like with the tangent ones that have 4 answers, or could have up to 4 answers,
Oh my gosh.
then
It's a little different.
yeah, it's a little different. And you do kind of need to check them all and make sure that they work, because sometimes they don't. It's not super often. Like I'm sitting here looking at them, and no, I should say a sine or a cosine one, if it is squared, could potentially have 4 values, which is the same technically with tangent, I guess. I was trying to look and see if I even see any that technically have something that would be extraneous. I don't, but you still have to check and make sure, so. Let's see. 18, so we're still on this interval for 16 all the way through 21. So 3 cosine of x is equal to cosine of x minus 1. So I'm going to subtract the cosine x from the right side over here. So this is like 1 cosine x, and this is, since this is 3, so we're going to subtract. So it'll be 2 cosine x is equal to negative 1. So then cosine of x is equal to negative 1/2. And then I just want to know where is cosine of x equal to negative 1/2. And if it occurs twice, I need both values.
2 pi over 3 and 4 pi over 2.
Yep. So then we check. So 3 cosine of 2 pi over 3 is equal to cosine of 2 pi over 3 minus 1. So this is 3 times cosine of 2 pi over 3 is negative 1/2 is equal to negative 1/2 minus 1. So that's negative 3/2 is equal to, well, that's negative 1.5, which is the same as negative 3/2. So that one's good. And honestly, as long as you know that 4 pi over 3 is negative 1/2, it's going to end up being the same thing. So you don't really have to check it. Just acknowledge that you at least looked at it. You need to check at least one. If you have like the squared ones, you need to check at least one of the positive and one of the negative ones, because that's where on occasion it will cause a problem.
Since these are both positive, we can just check one.
Because you know that they're both going to give you the same answer.
Okay.
So like both of these are -1/2. But if it had been cosine squared, let's say, no, obviously that's going to be a little different. But if it had been cosine squared, then there would have been the +1/2 and the -1/2. Obviously not for this problem, but let's just hypothetically say that was the case. You would have had 4 radian values. You need to check one of the ones that gave you the +1/2 and one that gave you the -1/2. So we'll see that here in this next one, because I'm gonna do a tangent squared problem. So it should happen with this one. So 5 tangent squared of x minus 15 equals 0. So you add the 15, so 5 tangent squared of x is equal to 15. Divide by 5. Tangent squared of x is equal to 3. So now when I take the square root, we do the plus or minus. So it's going to be tangent of x is equal to plus or minus the square root of 3. So what I would do is I would almost do the tangent of x equal to the positive square root of 3, and then tangent of x equal to minus the square root of 3. And write the 2 values under each one that are like where that occur, so that then when you check it, you can check one positive and one negative. So where is tangent of x positive root 3?
Pi over 3 and 4 pi over 3.
Okay. And negative root 3?
2 pi over 3 and 5 over 3.
So then I would check one of these, the pi over 3. So 5 tangent squared of pi over 3 minus 15. So tangent of pi over 3 is the square root of 3, right? Yeah. So then we square that. So that's going to be 3. So that's 5 times 3 minus 15 equals 0. So 0 equals 0. So that one's good. And then I just need to check a negative one just to make sure. So 5 tangent squared of 2 pi over 3. So that's minus the square root of 3, but since it's being squared, the negative sign's going away, so it becomes positive 3, so it's still 5 times 3 minus 15 equals 0. 0 equals 0, so those are good.
How come we aren't putting it as a square root of 3 instead of just 3?
Because it's getting squared.
Oh, okay.
So yeah, so really this intermediate step that I'm not writing is that this is minus the square root of 3 squared, and since it's squaring everything, I'm just saving a step of writing.
Yeah.
So, but yeah, no, you can obviously write it out if you want.
Yeah.
You don't have to. I think, honestly, we're going to stop there for now. If I feel like, hold on. Okay, we're going to jump and look at one more, actually. It's an odd one, but if you were to have one, it would purely be like this problem or one identical to it. There's not another one like it that's an even one, so I'm just going to do this one. More so just so you see it. It comes up in pre-cal. We just did something like this the other day. But sine squared of x plus 5 sine of x minus 3 equals 0. And it tells us that the interval is minus pi over 2 less than or equal to x less than pi over 2. So, ignoring the interval, does this look like anything you've seen before? Or like what would, like, if you see it, do you think of anything like, oh, this kind of looks like blah blah blah? What'd you say?
Parabola.
Okay, so a quadratic equation, I'm guessing, is where you're going with that. So yes, that's true. So what I'm gonna do is, yeah, maybe I could figure out how to solve this without a whole lot of effort, but also maybe not. So what I do is I use what we call U substitution. And this gets used a lot in calculus, U substitution. So basically, I say let U be equal to sine of x. So anywhere I see a sine of x in that equation, I'm going to replace it with U. Okay, I'm not using x because x is already used in the equation. So U is just, I don't know why, but it's just the variable of choice that's been used for a very long time. So I would say U squared plus 5U minus 3 is equal to 0. Now, they don't all end up being nice and pretty because is this factorable as is? No. So this would not really be pretty to do a completing the square with either. So you're probably going to get stuck using the quadratic formula. Which we'll try. The answer is weird. I should have known I was going to do this. But anyways, a lot of times they factor out nicely, and then you just get to plug back in, and it solves very, very beautifully. This one doesn't. Go figure. So -5 plus or minus the square root of 5 squared minus 4 times 1 times -3 all over 2 times 1. So, and this basically we say is equal to U. Okay, so we don't often write this, but when we do the quadratic formula, we're saying x is equal to that. Okay, so we're saying ultimately that U is equal to this number, or that the sine of x is equal to this number. Okay, so, but we'll plug that back in when we're done. So this is going to be -5 plus or minus the square root of, well, 25 plus 12, so it's like 37 over 2. So basically, you're going to end up solving this out, okay? We're probably just going to be content to replace U with sine of x and call that the answer. Now, technically speaking, only one of these is going to work. But what we would do then, if we were to continue, okay, so there's some stuff that's going to occur here. We would have x is equal to the inverse sine of blah, blah, blah. Whatever works, then that's going to give us out an answer. I don't usually give the ones that have the quadratic formula. I would give something more likely that has, if I were to give it to you. I probably won't, just because it's not a pretty one and there's not a good one in your book that does it. But anyways, it would give you out a nice, pretty answer. Like the one we had the other day, I think gave them out that the answer was like pi over 3. Like, it was pretty. I was like, okay, cool. This one, not so much. Just in case you're just so ambitious, this answer ends up being 0.572 when you solve. So, but all you would do is just whatever number this is, you would just take the inverse of it, and then the whole thing is, 1, checking to make sure it falls in the interval that you're given, and then 2, making sure like it works when you plug it in. So don't stress about that. I just wanted you to kind of see more so the setup. Like maybe what I would do is say set this up as if you were to solve it. That would be about the extent of me giving you this problem, unless it was something really pretty that factored. But again, probably won't happen just because you haven't had a chance to practice it. So any questions about these, the general solution, specific solution, anything? Just remember that sine and cosine are, we add 2 pi, tangent we just add n pi because of how it goes around. So, all right, then I am going to give you a couple to practice. Let's see, 3, 7, 9, 11, 17, and 19. So I've given you 2 of the general solution and then 2 specific solution problems. And I've tried to give you a tangent and then either a sine or a cosine just because they are different. So I would recommend maybe like before we quiz or test or whatever that you do practice probably one of the other ones like that's not given. So like if I give you sine and tangent, like practice a cosine, but I think you'd be fine with it. If you can do sine, you should be fine with cosine.